Right now, the world's most powerful governments and richest corporations are locked in a competition for dominance. Yet most people don't even realize it's happening. Historically, global powers fought for territory, oil, or military positioning. This conflict centers on a more abstract resource, the capacity to process information. Governments and mega-corporations are allocating hundreds of billions of dollars toward a single goal: artificial intelligence. Because AI can ingest information and refine its own logic, an early lead in development creates a technological gap that becomes increasingly difficult for rivals to close. For decades, scientists knew artificial intelligence was mathematically possible, but the technology remained trapped in research labs, constrained by the physical limits of early computer hardware. This graphic shows how that changed. Three distinct ingredients finally collided: an explosion of global data, new breakthroughs in machine learning, and the creation of highly specialized computer chips. Software became capable of writing, translating, and analyzing at superhuman speeds. Businesses recognized the potential to multiply output, while governments saw a strategic edge. This shift moved the technology from a subject of academic curiosity to an urgent strategic necessity. Companies began offering record salaries to researchers and expanding data centers, marking the start of a global scramble for survival. The steam engine mechanized manual labor, electricity standardized global industry. Artificial intelligence follows a similar trajectory, though its impact reaches into the realm of human cognition. At an economic level, these systems can automate complex administrative and analytical tasks. Entire sectors may soon perform the same amount of work with a fraction of the time and capital. In environments like these, operating rooms, algorithms will process diagnostic data at scale, allowing doctors to personalize treatments and engineers to solve complex scientific puzzles. The national security implications are equally significant. No superpower can allow an adversary to hold a monopoly over the systems that manage logistics, intelligence, and defense. Leading this field guarantees influence over the next century of civilization. In a world driven by algorithms, falling behind means losing the ability to compete on the global stage. It is easy to imagine that this competition is taking place entirely in code, floating in a digital cloud. But look closely at the infrastructure. Training an advanced language model requires millions of square feet of physical hardware, thousands of server farms, and heavy industrial cooling systems. The core engine for all this processing is the specialized silicon wafer. These computer chips are the primary bottleneck of the entire industry. Running hundreds of thousands of those chips simultaneously demands a continuous, massive draw on the electrical grid. Consequently, the countries that control raw materials, silicon manufacturing facilities, and national power grids will dictate who actually gets to build the smartest models. The compute data cycle logic. More computing hardware trains a more capable model, attracting more users. As users generate fresh data, it is fed back to train an even smarter model. The cycle accelerates, compounding early advantages until competitors cannot catch up. To keep this loop running, technology giants are doubling their infrastructure budgets, turning early investments of a few billion into commitments of hundreds of billions of dollars. The financial cost of simply entering the race has climbed so high that only a handful of the wealthiest corporations and sovereign governments can afford to participate. No one knows exactly where this technological ceiling is. We only know that every year, models demonstrate capabilities experts thought were years away. Some researchers forecast a future where algorithms solve biological puzzles and drive deep prosperity, while others warn of societal instability and unmanaged security risks. Regardless of these predictions, the data centers are built and the capital is committed. Society must now prepare to manage the consequences of a race that is already in motion. The global power structure of tomorrow will be determined by algorithms and computing power rather than traditional weaponry. This is not a hypothetical scenario. It is a live competition actively reshaping international alliances and corporate dominance. The infrastructure is set. The entity that crosses the finish line first will likely dictate the terms of the next century. The great wealth booms of the past had a distinct physical footprint. They happen deep inside mountains, out in the oil fields, or on the noisy factory floor. Today, a new rush is underway, but it is happening entirely out of sight, locked behind the cooling fans of unmarked buildings. Hundreds of billions of dollars are currently pouring into a technology sector that, in its modern form, barely existed a few short years ago. Entire national budgets are being matched by corporate spending. This massive influx of capital is minting new millionaires overnight. It is also forcing the world's largest, most entrenched corporations to aggressively pivot their entire operations to keep up. We are witnessing a historic structural transfer of capital happening right beneath our noses. Which raises an essential question: where is all of this money actually coming from? To understand the scale of this transfer, we must look at how past technological leaps behaved. The internet and the smartphone built massive empires. They created specific new industries that operated alongside the old ones. Artificial intelligence operates differently. It functions as a universal productivity multiplier. Instead of building an isolated industry, it is designed to increase efficiency across every existing system, all at exactly the same time. You see this universal application happening across finance, healthcare, education, retail, and manufacturing. No single sector is immune to the reach of these new computational models. Because the disruption is simultaneous, organizations face a stark reality. If a competitor integrates these systems and suddenly doubles their output, falling behind is no longer a slow decline. It is an immediate threat to survival. That fear of obsolescence has created a massive global vacuum for efficiency. Companies across the economic spectrum are essentially being forced to pump capital into the AI ecosystem just to maintain their footing. Before a single line of intelligent text or code can be generated, the system requires an enormous amount of physical power to simply turn on. The intelligence we see on our screens relies entirely on specialized silicon chips, sprawling data centers, vast cloud networking miles, and staggering amounts of raw electricity. Economists look at this structure as a stack. Right now, an entire economy is flourishing at the bottom, within this heavy infrastructure layer. In the 19th century gold rushes, the most reliable fortunes belonged to merchants selling the pickaxes and shovels. Today, demand for computational power is far outpacing the physical supply. The manufacturers forging these digital shovels are seeing their valuations rival the intelligence builders. If you remove this resource-heavy physical layer, the digital revolution immediately halts. The companies that control the hardware are the ultimate gatekeepers of the new economy. Above the heavy hardware sits the agile application layer. This is where entrepreneurs take raw computing power and mold it into accessible software. We are seeing a rapid expansion of startups building highly specific tools. These founders are writing programs to automate mundane corporate tasks, generate complex code, and process millions of data points in seconds. The financial logic here is straightforward. A business will gladly pay a recurring monthly subscription for software if it drastically reduces their daily operational costs. This creates a self-sustaining productivity feedback loop. Better algorithms attract more customers, driving up revenue, which is pumped directly back into training smarter systems. Every time this cycle completes, it spins faster, helping startups achieve massive valuations. This application layer serves as the engine of the money machine. It smoothly converts raw, expensive infrastructure power into accelerating, recurring corporate revenue. When you step back and look at the entire board, the real economic battlefield isn't isolated to the tech laboratories of Silicon Valley. It's playing out in everyday corporate offices around the world. The infrastructure giants and the successful software founders are clearly amassing great wealth right now. They are the immediate beneficiaries. But historical precedent offers a sharp counterpoint. The most profound, enduring wealth of an industrial leap is rarely captured by the very people who invent the tools. The true long-term victors emerge elsewhere. They are the traditional logistics firms, legal practices, and retail chains that learn to wield these tools. By drastically lowering their overhead, they multiply their profit margins in ways their competitors cannot match. The modern economy consistently rewards widespread adaptation and aggressive implementation over pure, isolated invention. The systems driving this capital transfer are not theoretical. The machine is fully operational right now, processing billions of dollars through the hardware grids and software subscriptions every single day. The sheer momentum of this capital flow marks one of the largest transfers of economic opportunity we have seen in decades. The time for debating whether this technology will affect global markets has passed. The structural shift has already occurred. The question now is strictly a matter of positioning. Who will step up and capture the wealth unlocked by this new efficiency? In an environment defined entirely by the speed of adaptation, the only guaranteed losers are those content to watch from the sidelines. What happens to artificial intelligence when it runs out of things to learn? The greatest threat isn't a shortage of computer chips or electricity. The real threat is running out of human knowledge. By themselves, these massive neural networks don't actually know anything. They learn by consuming the digital footprints we leave behind every single day. For the past decade, the formula for building smarter AI has been remarkably straightforward. You take an enormous amount of human output, books, articles, research papers, photographs, and social media posts, and feed it into the system. The more information the machine processes, the better it gets at recognizing patterns. Every click, scroll, and uploaded image provides the raw material keeping these systems running. Human data is the fuel driving the entire AI revolution. We tend to think of the internet as an endless library, a bottomless well of unique information that algorithms can drink from forever. But the reality is quite different. The vast majority of the web is overwhelmingly repetitive. The same news stories are syndicated across hundreds of sites, and the exact same concepts are rephrased millions of times. This line graph compares two critical trajectories. The steep curve going up represents AI's exponential demand for new training data. The flattening curve represents the finite supply of high-quality human information. We are rapidly approaching the point where these two lines intersect, a threshold experts call the AI data wall. When you exhaust that supply of high-quality data, the system stops making dramatic leaps in capability. Feeding an AI the exact same repetitive information over and over doesn't make it smarter. It requires entirely new, unique patterns to improve. So when the supply curve flatlines, the demand curve hits a ceiling. The tech industry has engineered a business model built for infinite, continuous growth. Yet they base that growth entirely on a resource that is strictly finite. Realizing that public data is nearly tapped out, technology companies are frantically changing their strategy. The race is no longer solely about building faster hardware. It is a massive hunt for non-public information. We are seeing aggressive new tactics emerge across the market. Companies are hoarding private datasets, negotiating expensive licensing deals with publishers, and locking away decades of previously accessible human knowledge behind corporate vaults. The reasoning is purely competitive. If you train an AI on rare, specialized expert knowledge, it will drastically outperform a competitor's model that only trained on standard, repetitive internet traffic. The next technology monopoly will be secured by whichever company controls the rights to the rarest human knowledge. Faced with this scarcity, companies proposed a seemingly logical workaround. If we are running out of text and images created by people, why not just use AI to generate new text and images, and use that to train the next generation of systems? It sounds like a neat solution, but it contains a hidden, self-destructive mechanism known as the algorithmic feedback loop. This cyclical flowchart shows how that loop works. You start with original human data, which feeds into an AI. That AI outputs synthetic data, which is then fed directly into the next AI as training material, creating a closed, non-human chain of information. This creates a digital mirror effect. With each successive generation of the loop, small errors multiply. Inherent human biases are amplified. Without fresh reality checks, the overall intelligence of the system degrades significantly over time. Substituting actual human truth with artificial generation does not expand machine intelligence. It traps these systems in an endless echo chamber, learning from their own degraded reflections. The era of easy AI growth, fueled by the vast open resources of the early internet, has ended. The industry is now facing a harsh reality. Companies that fail to bypass this data wall will quickly stagnate, unable to push their models past their current limitations. Authentic human creation, Original thought, genuine art, and true scientific discovery cannot be replaced by an algorithm. Because AI systems fail when they are forced to learn from their own synthetic outputs, they remain physically tethered to the human source. In an age of artificial saturation, the person at the keyboard has become the most scarce and critical commodity on the planet. The future of AI depends not on who commands the most powerful computers, but who maintains access to the most valuable resource, human knowledge. Discussions about the AI revolution often focus on the technology itself: billion-dollar companies, massive data centers, and futuristic robots. But the actual disruption won't be confined to research labs in Silicon Valley or government offices. It will manifest directly in your career, your income, and the tasks you perform every day. We can move past the debate of whether the world will change and start analyzing the specific ways it is already changing for you. Survival in this new economy depends more on your own micro-level adaptation than on the macro-level shifts of tech giants. There is a widespread, visceral fear that machines will replace millions of human workers overnight. History suggests a more gradual evolution. When desktop computers entered the office, they didn't eliminate the need for employees. They changed what those employees did with their time. The internet era followed a similar pattern, rebuilding how we access information and connect with one another without making the human element obsolete. The smartphone revolution then mobilized the workforce, further refining our daily routines and increasing general efficiency. AI follows this precedent by absorbing specific, routine tasks like parsing data, scheduling, or drafting basic correspondence, rather than entire careers. The primary competition in the workplace shifts from humans versus machines to individuals who use AI, outperforming those who attempt to work without it. This creates a human multiplier effect. When an individual integrates the right tools, they accelerate their own cognitive output far beyond their manual capacity. Advanced analytical software that once required a corporate budget is now accessible to anyone with an internet connection. One person can now manage the content and data output that previously required an entire department to sustain. As the cost of production drops, small, agile companies can compete directly against much larger, slower organizations. Removing routine friction allows ordinary people to identify and capture creative opportunities that were once economically impossible. It is often assumed that powerful technology makes human skills less relevant, but the evidence suggests a different outcome. If two professionals have the same access to AI, the one who asks better questions, understands the broader context, will consistently achieve superior results. This chart illustrates the shifting value of expertise. As AI handles high-volume mechanical processing, the demand for human contextual judgment increases. While software can synthesize information, it still requires a person to evaluate the weight of that information in a real-world scenario. Your role changes from being a doer of routine tasks to a strategic director of artificial intelligence capabilities. When machines can execute instructions with high precision, the human ability to decide exactly what to execute becomes the most valuable asset in the room. We are witnessing a divergence in the workforce, where the path forward depends entirely on new technological adoption. One path follows the professional who remains flexible, experimenting with new tools and prioritizing continuous learning. The other path is taken by those who assume their industry will remain static, ignoring the momentum of the changes already underway. For the individual, the risk of obsolescence comes less from the technology itself and more from the choice to remain stationary while the world moves forward. Over a 10-year timeline, the cumulative difference in output between a professional who integrates technology and one who resists it becomes a defining factor in their career trajectory. While headline stories focus on global arms races and data ethics, your personal preparation is what actually dictates your future. Artificial intelligence is a historical tool. Its final impact is dictated entirely by human intention and practical application. This future is built by those who choose to evolve alongside the technology, rather than waiting for it to happen to them. Your personal story determines the outcome of this transition. The focus now shifts towards how effectively you can prepare for a landscape that is already changing.